What's up guys, it's Simon Fiaz and today's video is on AQA Level Chemistry Paper 3, June 2018. Question 1. Explain why the use of large excess of H2O2 and I- means the rate of reaction at fixed temperature depends only on the concentration H plus aqueous. The idea that large excess of H2O2 and I-, so H2 concentration H2O2 and concentration I-, therefore remains effectively constant, therefore they have no effect on the rate, so it's going to be zero order. And then you could just copy that last bit. But in the real, when I'm doing my actual A levels, or when you guys are doing your actual A levels, you need to be just giving what the key points are, like the mark scheme points, and then that's it. You don't want to be waffling on because you don't have a lot of time, right? So H2 and O2 concentration H2O2 and I- therefore remains effectively constant, so have no effect on the rate zero order. Then explain what must be done to each sample before it's titrated with alkali. Stop the reaction by dilution. Explain how the graph shows that the order with respect to H plus A equals 0. Straight line graph therefore has a constant gradient as a concentration H plus changes and / decreases, or has a constant gradient as concentration H plus changes / decreases. Give the units at K1. Anytime it says use a graph to calculate value of something, 9 times out of 10 you just need to calculate the gradient and then that's it. So y2 minus y1 over x2 minus x1, calculate gradient and the units, moles per dm minus cube s to the power minus 1. Plot these results in the grid in figure 2, plot it, and then curved line of best fit. Then it says calculate rate of reaction when hit concentration H plus is 0.35. So what you do here is you'd go to 0.35, you draw a line here, and then you'd calculate the gradient. And it depends on what your answer is, really. I don't even know if I did this one correctly, but that's how you would approach that. 1.8, explain giving brief experimental details how you could use a series of experiments to determine the orders of reaction with respect to A. Each experiment should obtain a measure of the initial rate of reaction. Stage 1, the preparation. Measure known volumes of some reagents. Measure known amount of X. Use a colorimeter into separate containers. Stage 2, the procedure. Start clock at the point of mixing. Time recorded for appearance of blue color / disappearing cross. Use the same concentration of B and C. Same temperature. Use water bath. Repeat with different concentration A. Stage 3, use of results. 1 over time taken as a measure of the rate. Plot 1 over time against volumes / concentrations of A. Then interpreting order from shape of 1 over time. Use volume / concentration graph. Question 2, given equation, 2 observations for reaction when sodium heat with oxygen. 2 Na solid plus a half O2 gases to form Na2O solid. Now that is how well can you memorize the equation. Now the observations, they're not in my CGP textbook, so I'm gonna ask my teacher maybe on Monday, chemistry teacher, and then find out what are all the observations we have to memorize for period 3 elements and the oxides. And once I've done that, I'll make a video on that as well, because observations actually are the hardest part, because the equations, yeah, they're really simple memorizing, but the observations definitely harder. Again, 2.2, give equation where observation P4 solid plus 5 O2 gases to form P4O10 solid, observation white solid. Explain the increase in melting point from sodium oxide to magnesium oxide, increase in charge density from Na plus to Mg2 plus, therefore stronger forces of attraction between Mg2 plus and or stronger forces of attraction between oppositely charged ions, stronger ionic bonding. Explain why the melting point of the oxide silicon is much higher than that of the highest oxide of phosphorus. Silicon has strong covalent bonds between molecules / giant covalent / macromolecular, whereas phosphorus is simple molecular, has weak van der Waals forces between molecules. Strong covalent bonds require more energy to overcome compared to phosphorus, which requires less or no energy to overcome. Covalent bonds throughout silicon dioxide are much stronger than intermolecular force in phosphorus oxide, P410. I can't lie, I just waffled a lot. All you need to say, silicon has strong covalent, silicon giant covalent / macromolecular, phosphorus simple molecular, and then talk about that final point, covalent bonds. You don't really need that part. Describe a method for determining the melting point sample and state how the result. Use to evaluate its purity. Use melting point apparatus and increase temperature until sample turns from solid to liquid. Heat gradually to establish melting point range. Impurities have low melting points and a wide range of melting points. Then question 3. Now this is a year 1 practical, isn't it? Yes, it is. So again, showing how you need to know your year 1 content as well. Calculate percentage yield cyclohexene. Classic question. So the hardest part for this is working out the MRs, right? So I'm going to use density, mass, and volume. I find out the mass using the information given in the question. Once I've worked out the mass, I can work out the moles, 1-to-1 molar ratio, work out the theoretical yield, and I'm going to do 5.97 over the theoretical yield, 7.87 times 100. Again, the hardest part is working out the MRs of whatever compound you have. Describe a test tube reaction and product to show that cyclohexanol had been dehydrated. State what you observe. Add bromine water, goes from orange to colorless, decolorizes. Because we're going from cyclohexanol to here, cyclohexene. And what does this have? A carbon-carbon double bond. So therefore, I can use bromine water. Bromine water tests for the carbon-carbon double bond. So add bromine water, goes from orange to colorless, decolorizes. Suggests why sodium carbonate solution was used to wash the distillate. Sodium carbonate would neutralize / remove phosphoric acid / react with H3PO4. Sodium carbonate would neutralize, remove phosphoric acid. Explain why it's important to open the tap of the separating funnel periodically to avoid pressure buildup. Give a property of anhydrous calcium chloride under its ability to absorb water that makes it suitable as drying agent as preparation, doesn't react with cyclohexene. Scrap apparatus used to remove the drying agent by filtration to reduce pressure. Buckner funnel, a flat bottom funnel containing filter paper, and then a Buckner flask, a side-on flask connected to a vacuum pump. Can't go through 3.7, haven't gone through chromatography yet. Explain how the infrared spectrum would confirm that this did not contain cyclohexanol. I can't go through this. There'll be no additional peaks in the fingerprint region compared to a pure sample. 4.1 plot a graph of temperature against time. Now this one is, in my opinion, one of the most trickiest graph questions for this practical. Hydrochloric acid, sodium hydroxide. This, because obviously you've got Arrhenius equation, that's pretty tricky as well. Apart from that, this question is. So what you would do firstly is plot the graph, and then you need to remember that you need to draw 2 lines of best fit, one at 0 to 3 minutes, and then one at 6 to 12 minutes, and then you need to extrapolate both lines to at least the 4th minute, and then do the 21.9 minus 19.8 to get 2.1. Calculate percentage uncertainty in the value for temperature rise. So I'm going to use my answer from part 4.1. So 2.1 is going to be in the bottom. But because I've worked out temperature rise, I'm using 2 readings, right? So I know uncertainty each of temperature readings, use experiment with that. That's for 1 temperature reading. I've got 2. So I'm going to do 0.1 times by 2, 0.2. Over 2.1 times 100, 9.5%. Such a change to experiment that will minimize heat loss, use a lid. Suggest and explain another change to experiment to decrease the percentage of certainty in the use of the same thermometer. Increase the magnitude of temperature change by increasing the concentration of acid / alkali. Increase the magnitude of temperature change by increasing the concentration of acid / alkali. Give an equation for reaction between ethane dioic acid and potassium hydroxide. HOOC, COOH plus 2KOH, arrow K2 OOC, COO plus 2H2O. Then calculate enthalpy change for this. And again, this enthalpy change question, I've never really seen this before apart from this one. And in my opinion, this is one of the most tricky ones. Right? Because it's giving you 2 things, right? So first thing you're going to use obviously Q because MC delta T, M is mass of water, 1 gram per centimeter cube, 25 plus 75, 100. You can work out the mass of water, easily. Then delta H, so I need delta H is Q, which I can work out over moles. And then I need to identify what moles am I going to work out, because I've got concentration volume here, I've got concentration volume here. So what am I doing? So I work out the moles of the ethane dioic acid, I work out the moles of potassium hydroxide, and then I see that it's a 1 to 2 mole ratio, but the moles of potassium hydroxide is in excess. It's 0.045. Should be 0.040. So I'm not going to use that. I'm going to use moles of ethanediolic acid, right? And I want to calculate enthalpy change per mole of water. And I know water formed has a 2 mole ratio, so it's a 1 to 2 mole ratio. So whatever the moles of ethanediolic acid is, because that's not in excess, I'm going to use those moles. I'm going to times it by 2, so 0.040. And then Q, I need to divide it by 1,000 because I want enthalpy change in kilojoules multiplied by minus 1. Then I get 33.6. And then the final part is because I know it says in the question the temperature increased by 3.2 degrees Celsius. Therefore, it must be negative as temperature increased, therefore exothermic reaction. And it's just these tiny details that this question is really nice question to practice your skill on these type of calculation questions. And yeah, if you didn't even get the equation part right, you could at least get 1, 2, maybe 3 marks. Yeah. Or maybe, yeah, at least 2, maybe 3 marks. Such an explanation of the difference between this value and the answer to question 4.5. It says sulfuric acid potassium hydroxide minus 57, my value minus 33.6 with ethanoic acid and potassium hydroxide. The idea that ethanoic acid, HOCCOH, is a weak acid, not fully dissociated, more energy needed to break bonds. Actually, no. HOCCOH is a weak acid, more energy needed to break bonds, and dissociation is endothermic. So that's section A. Now, section B, the multiple choice questions. Now, I'm not going to go through it like I've usually done, but I just go through each one in detail. I'm just going to go through the answers and maybe give a general explanation when I can. Question 5, which can be both empirical and molecular formula of a stable compound. Definitely not B, that's not empirical formula. That can be simplified to P2O5. C, no, that's not going to be stable because NH2 go to NH3, NH4 plus. CH3, carbon can have 4, so that can go to CH4, so that's not going to be stable. Therefore, the answer must be A. And that's how you do that one. Which diagram shows the correct bonding and correct bond polarity in the molecule of oxygen difluoride? Now, what you need to understand is fluorine is the most electronegative element, and you've probably gone through this fact last year, maybe if you're in year 2 now like me. Fluorine is the most electronegative element, so fluorine is going to be delta negative, so I can cross out B and D, so I'm left with A and C. So if fluorine is delta negative, then what's going to be oxygen? Delta positive, both of them. But why do I have these arrows going to the oxygen? No, it's just normal like that. What conclusion can be drawn from the detection of He2 plus particles at point P? So at point P, well, it's gone through it, right? Gone through the gold. So it tells me that gold atoms are mainly empty space. What conclusion can be drawn from the detection of He2 plus particles at point Q? So I'm going from here, and it's deflected to here. But it tells me only 1 in 8,000. So it's going to have a positive nucleus, but it's going to be very, very small because only 1 in 8,000 were detected at point Q. Which equation represents a termination step? A is a propagation step, B is a propagation step, C is a propagation step, D is the only termination step, so that's a really nice one. Which statement is correct about molecules shown reacted HBr on an electrophilic substitution reaction? HBr. Alkenes undergo electrophilic addition with hydrogen halides. Yeah, electrophilic addition, not electrophilic substitution. So it can't be A. It reacts with sodium borohydride and nucleophilic addition elimination. No. If it's going to react with sodium borohydride, it's going to be nucleophilic addition. Nucleophilic addition elimination, not sodium borohydride. It reacts with ethanolic potassium hydroxide in an elimination reaction. One elimination reaction, an alkene is going to be formed, right? Yeah. I've already got that right. Therefore, the answer is going to be D, reacts with case in a nucleophilic substitution reaction. Which statement is correct about 2-methyl-butane 1 or 2-methyl-butane 2, or they can both be formed? It can be formed by alkaline hydrolysis of esters. Which is a possible rate equation for this reaction? When concentration W, X, and Y or double the rate of reaction increases by a factor of 4. Wait. I know rate equation, so
Okay, when the concentration of W, X, and Y all doubled, the rate of reaction increased by a factor of 4. Okay, so it can't be A or B, right? Because if that's doubled, W, then it's going to be 2 squared, so that's going to be 4 times by 2A. Same with that. So it must be C or D. Well, the thing about D is Z is your product rate equation. So therefore, and also it tells me that when these are doubled, so therefore it's going to be X and Y. Which graph will show the reaction second order with respect to X? Well, it can't be a B or C just by because those are not going to be second orders. So I'm left with A and D. With respect to X, it's going to be D. And you need to memorize those curves as well. I haven't gone through that, but yeah, you do need to do that. Which equation represents process that occurs the standard enthalpy of atomization of iodine is measured? Now, in all of these cases, I want now just by memorizing this, I need to form 1 mole. I'm always forming 1 mole with the standard, so it can't be B or D. 2 moles, 2 moles. So I'm left with A and C. Now, if I look at C, iodine is gaseous. Is it gaseous? No, iodine is going to be solid in this case. This is going to be A. Which structure is formed by aspartic acid in solution at pH 12? This was my thought process. That's a high pH. So with a high pH, low concentration H plus ions, when you go through acids and bases, you'll definitely get that part. Just very simple fact. So therefore, B and C are out of the equation because both of them have extra H plus, but my structure is going to have a low concentration H plus ion. So I'm left with A and D, and therefore the answer is going to be D. How many peaks are there in this? So 1,4-dimethylbenzene. Draw it out. And you should find out that there's 3 peaks. Which of these period 3 elements are highest melting point? Aluminium, phosphorus, sodium, sulfur. Phosphorus, simple molecular. Sodium, a metal. Sulfur, S8. Again, simple molecular, right? So it's not going to be phosphorus or sulfur. It's either going to be the metals. Aluminium or sodium. It's going to be aluminium, Al3 plus. Sodium, which is just Na plus. Chlorine reacts with cold dilute aqueous sodium hydroxide, which is a complete list of the products. Cl2 plus 2 NaOH, or NaCl plus NaClO plus H2O. Which products form when magnesium reacts with steam? Steam, Mg solid plus H2O gaseous to form MgO solid plus H2 gaseous. Which observation would confirm that ammonia gas is released when this is warmed with solid called calcium hydroxide? It's also obviously going to be red to blue. So I'm left with B and D. When touched onto it, no, it's a gas. So when it's just held above the solid mixture. Repeating unit, which monomer or pair of monomers used to make this polymer? C. Structured part of polyester chain is shown. Statement correctly explained that plastics made from polyester only soften at high temperatures. Permanent dipole forces and van der Waals forces exist between polyester chains. Which statement is correct? HNO3 acts as base. Which is the correct order of pH values of the solution? Ethylamine, which is greater than ammonia, which is greater than phenylamine. Which element forms an ionic oxide that reacts with strong alkalis? Aluminium. Which statement is correct about this reaction? Entropy change is large and positive. We go from 4 to 7 moles. Which complex exists of optical isomers? B and C. So that's this one. I don't know what in the mark scheme they made a mistake, I'm pretty sure. But yeah, B and C. How many structural isomers of this react with tolerance region? 4. Which ion cannot catalyze reaction between iodide and peroxide disulfate? B, Cr2+. Which species has a shape that is influenced by the presence of one or more lone pairs of electrons on its central atom? B, Clf3. Which pair of solution would give the greatest mass of solid? B, barium hydroxide, MgSO4. Which indicator should be used to titration for concentration of ethylamine using 0.01 moles per liter minus cube hydrochloric acid? B, bromophenol blue. Which compound shows the greatest percentage difference between these two values? D, LiL. For this reaction equilibrium, which combination of temperature and pressure will give the greatest equilibrium yield of products? Now, I know delta H is positive, so therefore endothermic. So if I want the greatest equilibrium of products, I'm going to increase the temperature because then it's going to shift to the endothermic direction, which is forward direction. So high temperature, pressure, well, I've got 2 moles, 3 moles, so I'm going to lower the pressure so it shifts to the side with more moles of gas, which is the right hand side. So low pressure and high temperature.
And that is the end of the paper. Now, these multiple choice questions should show you that you just need to know with paper 3 and multiple choice questions, you need to know the whole of the specification, the whole course, all the spec points and all of that. Like already here, you've got one multiple choice question that's testing your knowledge of the equations, another one testing your knowledge of equation, another one testing your knowledge of the practical skills, right? And then also a bit more to that as well, because it's a gas, so then held above. And yeah, this one testing about your knowledge on mechanisms. You can see, so you need to know all the content before you do your paper 3.